Today we're going to be talking about mixed numbers and improper fractions. So when we say a mixed number, we're talking about a number that has a whole number part and a fraction part. So in this case, this would be 1 2/3, because if you can look at the green ones, if you have 3 of them, it equals a whole. So we know that the green ones represent a third. So this would be 1 2/3. But if we wanted to make it into an improper fraction, and when we say improper, it doesn't mean there's anything wrong with it. It just means that the numerator is bigger than the denominator. That's the only thing improper about it. If we wanted to convert it to an improper fraction, we would trade this whole one out for 3/3. So this is the same, this represents this. So we're going to take this whole one out, and now we can see how many thirds there are. So there are 5 thirds. So 1 2/3 is the same as 5 thirds. This is mixed number, this is an improper fraction. So let me just try, we're going to do this again with a few different things, and then I'll teach you how to do it without the Cuisenaire rods. So let's look at this one. If we had 1, and these are fifths, so if I had 1 2/5, this is my mixed number, and I wanted to know what the improper fraction was, I would have to trade in my 1 for 5/5 to make it the same length. So now we can get rid of the 1, and we can count how many fifths it was. 1, 2, 3, 4, 5, 6, 7. So 1 2/5 is the same as 7/5. Let's look at another one. What if I did, let me see. These little ones here represent a 1/10 when we're using the orange one as a whole. So it's going to take 10 of these white ones to equal a whole. Okay, so here we have 1, so now I can get rid of the 1, and 2/10. So the mixed number would be 1 2/10. And the improper fraction, you'd have to count them all, but we know there's 10 of them right there. So 10, 11, 12. So the improper fraction would be 12/10. Okay, let's try another one. Let me see. If we use the brown as a whole, and we use the purples beside it, let's see what happens. It takes 2 purple ones to equal 1 brown. So that tells us that each of these is 1/2 of the brown one. So let's say I can take this away now because we know this represents 1. If I had 1 1/2, that's my mixed number, how many halves do I have? 1, 2, 3. 3 halves. In this example, my mixed number is 3 2/3. So 3 wholes and 2/3. If I want to convert that to an improper fraction, I have to trade each of these for 3/3. So I'm going to trade this one out for 3/3. 1, 2, 3. I'm going to trade this one out for 3/3. I'm going to get better at this as I go. This isn't going as well as I could, but that's all right. And then I'm going to trade this one for 3/3 as well. 1, 2, 3. So now I still have 3 2/3, but if I wanted to tell what the improper fraction was, I would have to count up all of these thirds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it would be 11 thirds. Using that same question, 3 and 2/3. If we don't have the rods to work with, we have to have another way of doing it. So that's what I'm going to talk about right now. How can I convert a mixed number to an improper fraction without using these rods? Basically what you do is for the 3 whole ones, remember we traded each of these for 3 green ones? It's the same as saying 3 whole ones times 3 green ones. So 3 times 3 is 9, but I'm not finished. 3 times 3 is 9, so just hold that number in your head, 9. Then we have 2 more thirds, so we have to add those to the 9. So 9, 10, 11. So I have 11 thirds. Another example would be this one, 2 whole numbers and 4/5 of another. So 2 and 4/5. We could trade these in for 5 for each of them, but we're not going to do that. We're going to do it on paper. So we have 2 whole ones. There's 5 in each, so 2 times 5 is 10. And then we have 4 additional fifths. So we're going to add those ones on. So 10 plus 4 is 14 fifths. Now that we've learned how to go from a mixed number to an improper fraction, let's try doing it the other way around. This time we're starting with an improper fraction. It says we have 12 fifths. So using the rods, if we know that each of these is a fifth, it's going to take 5 of them to equal 1 whole. So there's my first whole. 1, 2, 3, 4, 5. There's my second one. And then I have 2 left over. So from this, we can see the 12 fifths equals 2 whole ones, so 2, and 2 fifths left over. So 2 and 2 fifths. I'm going to also show you how to do it without using the rods. We're starting with an improper fraction, 7/3. So we have 7 of these little 1/3 pieces. If we wanted to know what the mixed number was, we would put 3 equals 1 whole, 3/3 again equals another whole, and then there's 1 left over. So we have 2 whole numbers and 1/3 left over. So how do we go from an improper fraction to a mixed number if we don't use any of the rods? There is a way to do it pretty simply. Basically, you say, how many times does 5 fit into 17? You're dividing 17 by 5. So 5 fits into 17 3 times. That's our whole number. But then there would still be 2 fifths left over. So 2 fifths. Let's try another one. If we had 18 fourths, how many times does 4 go into 18? 4 times. So your whole number is a 4. But 4 times 4 is 16. And this is 18. So there's a remainder of 2. That remainder becomes your fraction. There's 2 fourths left over. Notice that the denominator is going to be the same in both. If you feel like you know what you're doing, you can go ahead and start page 293 in your textbook. If you feel like you need a little bit more help, I'm going to work through the first few questions at this point. So if you'd like to quit watching the video, you may. Otherwise, stay tuned. So if you're still with me, I'm going to go over question 1 on page 293 with you. I drew it out because you have it there in your textbook. If you could look at it while we're doing this, that would be great. The instructions for question 1 say, write an improper fraction and a mixed number to describe each picture. So let's look at 1A. It's a triangle that's been cut in half, and the green lines represent the half that's not colored in. So basically, we know we're going to be talking about halves. So how many halves do we have? We have 1, 2, 3. So the improper fraction would be 3 halves. The mixed number, how many whole triangles do we have? 1. And then we have 1 half left over. So basically what you have to do is see how many pieces the shape is divided into before you even get started. Here, it was divided into half, so we know that we're going to be dealing with halves. In this question, the shapes are divided into fours, so we know our answer is going to have to do with fourths. How many fourths, if we're going to do our improper fraction first, how many fourths do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So our improper fraction would be 13 fourths. Let's talk about the mixed number. How many whole shapes do they have? Well, there's 1, 2, there's 3 entire squares, but then there's this one little fourth left over, so that's the fraction part of your mixed number. Let's look at C. How many pieces did they divide the circle into? They divided each circle into eighths, so we know our answer, we're going to be dealing with eighths. Okay, now the question is, for our improper fraction, how many eighths are there? Well, there's 8 for each pizza. I could count each individual one, or I could count by eighths. 8, 16, 24, and then I count the remaining, 25, 26, 27. So there are 27 eighths. I'm getting new pens supposedly today in Amazon. I'll be very excited to get those. So that would be our improper fraction. Our mixed number, how many whole pizzas are there? 1, 2, 3. So our mixed number is 3. And how many pieces left over? 1, 2, 3. And we know that they are eighths because the pizzas were divided into 8 pieces. So improper fraction, mixed number. Question 2A, we're supposed to draw a picture to represent each number. So you have to draw something. You could draw a square and divide it up. You can draw a circle, it doesn't matter. But you know you're going to have to divide it into 8 pieces because we're talking about eighths here. So I'm just going to do a circle because I find that's pretty easy to divide into 8 pieces. First I'll divide it in half, quarters, and then eighths. So I have one whole circle, there's my one whole one, and 5/8 of another. So the way you can represent this is to color it in. It's probably your best way to show 1 and 5/8. So you could color in the entire first circle and then 5 of the second one. So that would be a picture to represent the number 1 and 5/8. Next question, 1 and 2/3. Let's try using a rectangle for this one. We're going to divide it into 3 pieces because we're talking about thirds. So if I have this rectangle, I have one whole one and 2/3 of another one. Now, this is not going to be exact because I'm just drawing it, but it looks like about a third. So I have one whole one and then 2/3 of another one. So that's my drawing for that. C is a bit different because it's not starting with a mixed number, it's starting with an improper fraction. But we look at the denominator and we see that it's a 4. So we know whatever it is we draw, we have to split it into 4 pieces. And we know we're going to have 7 fourths. So here we have 1, 2, 3, 4. So I have to draw another circle and divide it into fourths. So 1, 2, 3, 4, 5, 6, 7. The picture represents 7 fourths. I'm going to get you to do question 9 on your own. You're going to split whatever you draw in half. And you might need to draw a few of them because you have to color in 9 halves. Let's move on to question 3. The instructions say write each mixed number as an improper fraction. So 3a is 1 and 1/6. So if you remember from the lesson, the way to convert it to an improper fraction is you multiply the denominator by the whole number. So 1 times 6 is 6. And then you add the numerator on. So 6 plus 1 is 7. So you're going to have 7 6s. Question 4 is just the opposite. Write each improper fraction as a mixed number. So for question 4, they start with an improper fraction. So the first one is 17/5, and you're going to convert it to a mixed number. If you remember from the lesson, the way to do that is you're dividing the numerator by the denominator. So you can say to yourself, how many times would 5 fit into 17? Well, it fits in 3 times. 5 times 3 is 15, but that leaves us with 2 left. So it's going to be 2. And how do we know what goes on the bottom? Well, we look here, it's going to stay the same. So it's 2/5. So I would like you guys to do 3a and 4a, and then try and finish question 3 and question 4 on your own. The last question I'm going to try and help you with right now is question 5. The question says, which of these improper fractions are between 4 and 5? And how do you know? To be honest, just looking at them, I don't even know. So how am I going to figure it out? Well, I have an improper fraction right now, and I want to know if it's between 4 and 5. That means I'm going to have to convert it to a mixed number. So again, 3. How many times does 3 fit into 13? 3 times 4 is 12, but then we have 1 left over, so 4 and 1/3. Is this number in between 4 and 5? Yes, 4 1/3 is in between 4 and 5. Next question, 13 divided by 4, or how many times does 4 fit into 13? Think about it for a second. 4 goes into 13 3 times. 3 times 4 is 12, so we have 1 left over. And again, how do we know what to put on the bottom? We just look at what is being used already. Okay, 3 and 1/4, is that in between the numbers 4 and 5? No, it's not. Next question, 7/2. 7 divided by 2, or how many times does 2 fit into 7? 2 fits into 7 3 times. 2 times 3 is 6, but you have 1 left over, so it becomes 3.5. Is 3.5 in between 4 and 5? No, it's not. And the last one, 19/4. 19 divided by 4, or how many times does 4 fit into 19? We know that 4 times 4 is 16, and then there would be 3 left over, so it would be 4 3/4. Is that in between 4 and 5? Yes.